Here's something that should stop every developer in their tracks. 41% of all new code is now written by AI. That's not a prediction for 2030. That's happening right now. But here's what the hype machine doesn't tell you: a real developer just documented exactly where AI coding falls apart. And the answer might surprise you. Meanwhile, the British military is betting that AI can do something even more complex than write your apps. They want it flying armed drones alongside Apache attack helicopters, making split-second decisions in combat. Today, we're looking at two stories that reveal where AI is genuinely useful, where it's still dangerously overhyped, and what happens when we start trusting machines with increasingly high-stakes decisions. Let's start with the coding story. Ars Technica just published a fascinating first-person account from a developer who decided to build a real tool using what's called vibe coding, and then had the honesty to share exactly what happened. First, some context. Vibe coding is a term coined by Andrej Karpathy, the former AI leader at Tesla and OpenAI co-founder, back in February 2025. In his original description, Karpathy explained it as coding where you, quote, fully give in to the vibes, embrace exponentials, and forget that the code even exists. The idea is that you describe what you want in plain English. The AI generates the code, you hit accept all without reading the diffs, and when errors pop up, you just paste them back to the AI until things work. Karpathy himself admitted this approach means, quote, the code grows beyond my usual comprehensions, and sometimes when the AI can't fix a bug, you just, quote, work around it or ask for random changes until it goes away. He called it fine for, quote, throwaway weekend projects. So what did this Ars Technica developer actually build? A log colorizer, a utility tool that takes raw log files and applies color coding to make them easier to read and debug. It's not a trivial project, but it's not building the next operating system either. It's the kind of practical tool that sits in that interesting middle ground where AI assistants could genuinely help. The developer documented their entire workflow, the prompts they used, the iterations required, where the AI generated brilliant solutions, and critically, where it completely failed. This wasn't a marketing demo with cherry-picked examples. It was a real practitioner shipping real code. This piece matters because it cuts through the noise. The AI coding space is drowning in hype right now. Tool vendors claim their products will replace developers. Skeptics claim AI-generated code is universally garbage. Neither extreme reflects reality. What practitioners actually experience is far more nuanced. AI coding tools excel at boilerplate, at translating clear specifications into working code, at suggesting patterns you might not remember off the top of your head. They fail at understanding architectural context, at maintaining consistency across large code bases, at knowing when their confident-sounding solutions are actually wrong. The 41% statistic I mentioned earlier, that number is real, but it doesn't mean 41% of software engineering judgment has been automated. It means typing has been partially automated, and there's a huge difference. For developers watching this, the practical takeaway is that vibe coding works best for bounded problems with clear specifications, exactly like a log colorizer. The moment you need the AI to understand your broader system, your team's conventions, or make judgment calls about trade-offs, you're back to doing real engineering work. The developers who thrive in this environment will be those who understand AI as a powerful but limited tool, not a replacement for thinking. What should you watch for? Keep an eye on how the narrative around AI coding evolves as more practitioners share honest experiences. The tools are improving rapidly. Claude, GPT, and others release significant updates monthly. But the fundamental question remains: can AI ever understand context the way human developers do? That's the frontier worth watching. Now, if AI struggling to understand context in code seems like a manageable problem, consider what happens when the stakes are infinitely higher. Because while developers debate whether to trust AI with their pull requests, the British military is asking a far more consequential question: can AI be trusted to make autonomous decisions in combat? That brings us to Project NY. The UK Ministry of Defence announced in late January 2026 that Project NY, their ambitious autonomous drone wingman program, is advancing into prototype development. 7 major defense contractors have been selected to design drones that will fly alongside Apache AH-64E attack helicopters and operate with significant autonomy. The selected companies read like a who's who of defense technology: Endural Industries, BAE Systems, Leonardo, Lockheed Martin UK, Scios Aerospace, TechEver, and Thales. These 7 were chosen from 18 applicants, after a rigorous pre-qualification phase that concluded in late 2025. Here's what makes Project NWIGS particularly significant. These drones will operate on what the mod calls a command rather than controlled principle. That's military speak for autonomous decision-making within mission parameters. The human pilot in the Apache gives high-level commands, and the AI figures out how to execute them, adjusting to complex battlefield situations in real time. The technical requirements are substantial. These drones need to carry payloads above 250 kilograms, that's 550 pounds, which could include guided munitions, surveillance sensors or electronic warfare equipment. They need to match the Apache's speed and range, which is considerable. And they need vertical takeoff and landing capability for deployment flexibility. The timeline is aggressive by military standards. By March 2026, just weeks away, the shortlist will be reduced to 4 suppliers. Those 4 will receive contracts for research and development, with a live demonstration targeted for 2027 and initial operational capability by 2030. The goal is to align these drones with the Apache fleet's modernization cycle. This isn't theoretical. The mod explicitly stated these systems will perform reconnaissance, surveillance, strike missions, and electronic warfare in contested areas. Project NWIGS represents something genuinely new in military aviation. While the loyal wingman concept has been explored for fighter jets, the US, Australia, and others have similar programs. Applying it to helicopters for ground support operations is a different challenge entirely. Helicopters operate closer to the ground, in more complex terrain, with faster changing tactical situations. The command rather than controls principle is the crux of the matter. In traditional drone operations, a human pilot controls every movement. That requires constant communication links and limits how many drones one person can manage. Autonomous wingmen flip that model. The human sets objectives, the machine handles execution. This is where AI moves from digital abstraction to physical consequence. A coding error in a software tool means a bug report. An AI misjudgment in a combat drone means something very different. The UK's Strategic Defence Review explicitly frames this as, quote, pivoting to a new way of war using uncrewed and autonomous capabilities to generate what they call mass and lethality. The partnership structure is also telling. Anduril has teamed with GKN Aerospace for airframe manufacturing. BAE Systems partnered with UK startup Certo Aerospace. Thales is leveraging their experience with the Schiebel Chemcopter and Watchkeeper systems. This isn't one company building a drone. It's an ecosystem building a new category of weapon system. The immediate milestone is March 2026, when the field narrows from 7 to 4 contractors. Watch for which companies make that cut. It'll signal which technical approaches the mod finds most promising. Beyond that, the 2027 live demonstration will be the first real test of whether autonomous rotary wingmen can perform in realistic conditions. And keep an eye on parallel programs worldwide. This is becoming a global race. What strikes me about these developments is the spectrum of trust they represent. In coding, AI makes mistakes and developers catch them. In combat, the margin for error is fundamentally different. As these systems advance, the question isn't just whether AI can do something, it's whether it should, and who remains responsible when things go wrong. That's the conversation that matters. If you found this useful, subscribe. We cover AI and tech news daily. See you in the next one.